If you had watched my previous two uploads, I now wouldn't have to tell you that I'm making a holder for some internal turning tools. So far I did some drilling and reaming and a bit of fly cutting, and it is really starting to look like a tool holder, especially when you insert the tool. In this video I will put in some set screws using these super cheap Chinese tabs, and I'll make another modification that may or may not work. And finally I'll top it off with some testing. That is, if everything goes as planned, of course. These here are 3 sets of M3, 4, 5, 6 and 8 tabs. I bought them so I could break them in the spark erosion machine testing video. Unfortunately, the Chinese postman took his time, and these never made an appearance in that video. But I like to find out what I can do, as some of the tabs in my tap and die set are getting a bit dull. These thingies are uncoated, but for €2 something a set you cannot really expect a decent coating, I guess. I do prefer tin coated tabs, you know, the gold color ones. They are a bit like shiny man jewels. I did some layout and marked the locations for the set screws. Feels a bit magnetic. That's annoying. The flats on this 20mm tool are 8mm wide, so I'm going to use an M8 set screw, and these are 6mm wide, so they get a M6 set screw. Although I am considering using M6 for all set screws. With the M8 the wall thickness becomes a little thin around here, and it might actually interfere with the washer, although it should sit below the surface, and with all M6 set screws you only need one Allen key. I'm not sure what I'll decide, but I guess you will find out. I just checked the squareness on my drill press table, and it's actually not bad. It is certainly within my tolerances. I am using a scissor jack to prevent the table from flexing, because it is kinda important that the set screws are square to the tool bit. I think I'll start with drilling some center holes. I must do something about that. I'm using 2 pieces of high-speed steel to prevent the workpiece from tipping over. Damn oil makes it harder to see. At this point I am a bit envious at people with a nice mill and DRO. Something that looks about right. And it moved, of course it moved. Okay, that looks good. The drill press is running about 500 RPM. I know I should be running faster, but I never changed the belt on this drill press, and I'm not about to start. Done. That went better than expected. A couple of videos ago you might have heard me complain about the poor state of my 10mm drill bits. The same day I recorded my complaining, I did some googling and came across cobalt drill bits. After watching a couple of reviews, I bought these cobalt drill bits from Banggood, and to my surprise they arrived already last week. That might be a new record, but on the other hand I am still waiting for something I ordered more than 6 weeks ago. Anyway, since they are here, I think I should try them out on camera. They certainly look a lot better than those bright drill bits I reviewed last year, and these even have split points. This set goes from 1.5mm to 10mm with half step increments. They cost about €7 something, although I did get them a bit cheaper because I had some Banggood points to trade in. You might want to check out Pierre's Garage's video. He tested the same drill bits on steel with different kind of hardnesses, and these definitely win from the other drills he was testing. I thought these were kinda impressive for how cheap they are. I don't believe they are coated, but for me that's not really a problem. At some point they will need to be reground, and then you'll lose the coating anyway. $5mm, that's the one I'm going to try. It looks good, feels sharp. I'm sure it will drill a hole. I just put all drills into my drill index, and it looks like I lied. There is no 7.5, 8.5 and 9.5 drill. So I guess the deal isn't as good as I thought it was. I set things up using my homemade clamp to prevent this and this from happening. Let's add a bit of loop and drill a hole. Look at that, it drilled a hole. Nothing wrong with that, but also nothing special. I guess more testing will be needed to make an informed opinion about these drill bits. I'm especially interested in how these split points hold up over time. I'm also using this clamp so everything stays in the same place, and I can line up the tab using the drill chuck. I had a close look at the cheap tabs, and it turns out that I actually have two different versions. The lettering is not the same, and the tab in the middle here is actually not as nice as those two on the outside. There's a very small burr on the tip of almost every cutting edge. It gets hard to see with the smaller tabs, but you can definitely feel it. So you never know what you're going to get when buying cheap tabs from China. I will use the better tab and give these to my brother. He'll probably never use them, and it feels better than throwing them away. They'll probably still work. Alright, let's tap a hole. I'm only using the drill press to get things started. I'll probably have to finish this in the vise, because I'm pretty sure it's going to slip in the drill shock. It's getting hard to turn by hand, so I'll take it out and finish in the vise where I can use a proper tapping wrench. I think I'm through. I think that was easier than the last time I was tapping this material. But those taps of mine are getting a bit dull. So I think this one is actually sharper. Let's see if I can finish this without breaking the tab. It goes in, although there is more resistance than with the other one. Yes, I'm through. My record is safe, because I never broken a tab unintentionally. Haha! The thread in here definitely doesn't look as good as this one. Let's try them out. See if I can notice a difference. Goes in easy. Is a bit sloppy. Maybe the hole was too big. Not much of a difference. Feels about the same. This one looks a little better, but maybe that's the light. I'm not sure. But threading on the first one was definitely a lot easier. I thought that there was a lot of play on those threads, and it's not the bolt I was using. It's the same with this set screw. So I drilled another hole, and as you can see, it is also pretty sloppy. The shank of the drill bit is 4.95 millimeters. Perhaps the flutes of the drill bit are ground uneven, or maybe it's the run out in the drill press. It could even be my setup that's the problem. I don't know. But this is way too big a hole for a decent M6 thread. So I'm going to switch to a 4.8 millimeter drill bit that I used once to ream a hole to 5 millimeter. It's also a split point drill bit, and it might even be also high speed steel with cobalt, because it has the same color. I wonder how they get this color. Is it the cobalt, or do they throw a bit of copper into the mix? 4.8 millimeter. Here we go. That drill certainly went well. Now let's get a tab going. Well, that's certainly a tighter fit. This is the 5 millimeter drill, and it doesn't go in there. The shank of the 4.8 millimeter drill bit is 4.72 millimeter, and the shank of the 5 millimeter drill bit was 4.95. So we know that the hole is somewhere in between, and that is possibly a bit too tight for the M6 tab, but I'm gonna try it anyway. Let's get this started. I just did a couple of turns on this tab, and it is definitely tighter. So I took it out again to clear out the chips, and now we'll continue. I may have a broken tab removal machine these days, but I do prefer not to break the tab. It feels really tight now. I know from past experiences this is a rather tough material to thread. Yeah, I'm through. Well, let's try that M6 bolt again. That might be a little better, but I'm not impressed. Yeah, it is a little better, but still not impressed. I will now finish the last two set screw holes, but I won't bother you with that. But I am disappointed with how loose the threads are, and it's pretty much the same on all of them. I don't feel any noticeable difference between the 4.8 and the 5 millimeter drill bit. I used all three of the tabs on two holes, and the thread the bad looking tab makes seems to be just as good as the other two, although it was harder to thread with that bad looking tab. They are sloppy, but they'll probably work fine. Alright, now I'm going to put in a few more set screws. I just marked the locations for some extra set screws, and these are going to be tiny ones, M4, and these will go on the outside of this flat here. and hopefully they will allow me to rotate the tool bit just a little bit, so I can raise and lower the cutting tip. Not sure if it will work, but it shouldn't hurt to try. So let's drill some tiny holes. I need a 3.3mm hole for an M4 tab, but that's not part of the Cobalt drill set I bought. So I'm going to try out this 2.5mm Cobalt drill bit, and then enlarge the hole to 3.3mm. I probably should speed up the drill, but I'm still too lazy to do that. It's done. No drama. That was easy. Now let's get the tab started. It's in. I'll finish on the vise. I've already threaded the other hole, which got pretty hairy. Unfortunately, I forgot to turn on the camera, but my perfect tapping record is still intact. Don't think brake cleaner is a good lubricant. I'll take it out and clean up the fluids. I'll take it out again. The fluids are filling up again. A little piece broke out on the tip of the tab. Hopefully you can see that. I switched to another tab. Tiny tab versus the toughest scraptonium known to man. Probably a recipe for disaster. Yeah, I think I'm through. Yes. and another small victory. And I kept my record intact. Haha! I just reamed out the burrs from the drill holes. And I guess now it's time to find out if my idea works. Well, here's a top tip for you guys. Those Banggood boring bar cases are perfect for protecting tapers. Before I can start testing my idea, I need to make these set screws slightly convex. And I'll probably have to do the same with the M6 set screws. I think this should work. I've been playing with these set screws for a bit, and although they are not able to rotate the tool very well, they do allow me to set the tool tip height, and they seem to work well enough. So I went through some more tapping agony and did the same modification for the 16mm bore. Now you might ask, why all the extra work? Why not just shim the tool holder up a bit? From my experience with the 4-way rotating boring bar holder, I learned that the tool tip height seems to be rather random, and it is a bit low most of the times because the tool shank is slightly too small and the bore is a bit bigger than it should be. Granted, these set screws are rather small, but even with bigger ones, my machining and the set screws would not be precise enough to end up with the same tool tip height every time I tighten the set screws. So for my machining abilities, this was the best solution I could think of, and I guess time will tell how good it works. I also considered angling the drill press table a few degrees so the set screws would sit on an angle and basically force the tool tip up, but that idea also got dismissed because of my limited machining precision. I even thought about putting in the set screws from below, but that's just plain stupid. Installing more of the same bigger set screws in a zigzag pattern might work, and it could be a solution for smaller tools with smaller flats. If you have any thoughts about set screws, let me know in the comments. The perfect solution might be out there. Now I know I said I was going to do some testing on this tool, but I've already done some editing and I'm quickly coming up on the 30 minutes mark, and no video about set screws should be allowed to pass the 30 minutes mark for obvious safety reasons. Although there is a good possibility that no one actually has made it to this point. So to all of you who couldn't make it this far, you're a bunch of pansies. And to the 2 people who are still hanging around, wake up! Time to buy some drill bits. Affiliated links in the description below the video.